Can't see myself on YouTube too, but it's streaming from OBS. Okay.
Do you believe in living life being fully awake? Well, it turns out that that's not the most optimal way to truly navigate life. Western society...
Okay, I think I'm now there. Hi guys, sorry for the delay. It's been a delay for about how long? 15 minutes. Right. Check. Am I audible? Could you guys just put it on the chat? Okay, I think the audio that you were hearing was from the Mind Valley ad, which was coming from the YouTube stream. So that tells me about the delay that's there between what I'm saying and what you're hearing. There's quite a lot of delay. Okay, there's actually a lot of delay. Fine. Okay, we can't really help that. So I'll have to do some mental calculations, so that okay, when I trigger, you will immediately see the question. So I need to trigger it before and then continue speaking, I guess. Let's see how it works. I don't really know how to process this delay in my head. Okay, so anyways, guys, hi. It's been a long time. Today we have a quiz on projectile motion. I think you already have the schedule, or if you don't, then I'll just ask tuition.in to put it on the WhatsApp group that most of you are a part of. For those of you who are on YouTube, please download the tuition.in app and attempt these quizzes for free from there, as I've been selling in all my previous sessions. And just let me tell you, the connection looks good. It has to be good because I'm streaming it from my mobile data. But in case the connection fails in the middle, don't worry. I will switch the network immediately and be back within a minute. So that can happen. We have to be prepared for that. But yeah, anyways, that's all that I had to say. Let's just begin from the first question. I'll just first display it on the screen. So you have a particle with some initial velocity, you have a constant force, and you need to find the path of the particle. Now, what happens is force imparts an acceleration to the body, right? Force always imparts an acceleration to the body. It might or might not. That's what I'm saying. It need not impart an acceleration, but if force imparts an acceleration to the body, change its path under the influence of the acceleration, right? Which means if a body is moving like this, you apply some force, it will provide an acceleration in this direction, then the body will start speeding up. If you give the force at a certain angle, then this force can change the path of the body, also change the direction. So you have a certain particle with some velocity here in the question, you have a certain force. What I need you to find is how will this force impact the position of the path of the body? How will the path of the body be as a function of this, as a result of this force, right? So yeah, I think that's all. And we are on question number 1, are we? Oh, why am I seeing question number 10 here? Just give me a minute. I am not able to access question number 10 over here. Let me just, till then you guys just have a look at the question. If there is a problem, we'll have to tell the team. I think there are too many technical issues today. Okay, now I can. No, I still can't. I can't get the first question. I don't know how to trigger it, so I'll have to inform the team. I can't get to the first question. on the trigger portal. Oh, somebody saying video is stuck. Don't worry about the video. Video is a very small problem to handle in situations like these. You know, there are bigger problems which keep coming, sometimes related to connection, sometimes related to triggering of the questions. The video is here. Okay, I think the delay is slightly handled better now. So as of now, the issue is that I am not able to trigger the first question. So if I am not able to do that, we will most likely, I'll get it manually done from the team. Okay, yeah, now I can, so I will immediately trigger it. Yeah, I've triggered it. Now you guys can attempt. 30 seconds where we'll get the time increased, don't worry. First question. But yeah, just give an attempt. This question anyways doesn't require a lot of time. Okay, let's see the stats. Stats are available. No, they are not. Fine, that's all right. Anyways, the answer to the question is parabolic path. And why is it parabolic? Let's quickly see that. So let me go and let me draw for you. Draw, and here is it. Yeah. So this is the velocity vector. Okay, let's say this is v is equal to 3I plus 4j, right? How is the force? The hint here is observe the force properly. Force is actually perpendicular to velocity here at every instant of time. How can I say it's perpendicular? Take the dot product of these two vectors. Take f dot v. If you take dot product, then you'll have 3 into 4. I hope you know how to take a dot product. If you don't, you have to revise vectors. 3 into 4. So 12 minus 12, 0. If dot product of two vectors is 0, then either one of them have to be 0, which they are not here, or they have to be perpendicular. So force and velocity are perpendicular. So isn't it something like, you know, you have a, okay, wait, what did I attempt here? So this is your velocity, and this is force, which is perpendicular. Okay, so the point is, what is the path of the particle? You know, the one thing here is that this velocity is not going to be perpendicular at all instances of time. That is what you have to understand, right? So you know what situation they are talking about. It's something like this. When you have your parabolic path, when the body goes on top, it has a certain velocity v, and it has a force, gravity force acting on it downwards. It is perpendicular only at the topmost instant, but at other instances force is still downwards, right? As you can see, force has a fixed direction and magnitude. So force is not changing with velocity. Force is constantly downward, or in some other, you know, I can't say it's downward here. Force is some vector, right, which is fixed. Velocity, I don't know how it is, but at some instant it is perpendicular. So obviously it's just very similar to your parabolic path, right, where gravitational force becomes perpendicular to velocity at the topmost point, and for the rest of the path force is fixed and velocity vector, you know, just keeps changing. So this is parabolic. That is the you know, you just have to relate this situation to your projectile motion that you have studied, right? This is very similar. Imagine this force as your gravity here, and imagine this velocity as the topmost velocity here, and yeah, that's all. That way you can relate this to projectile motion, and then you will know that the path is parabolic, right? So enough discussed. Let's move on to the next question now. Okay, shit, it's here. Let me go to the second question. Just have a look at it quickly. Identify the correct statement related to projectile motion. Oh, I think there is a diagram missing here, or is it? Let me just check. Okay, no, there's no diagram here actually, right? It is uniformly, what can we say about projectile motion? That's the question, right? Just read it and just attempt. This is going to be a simple one. These are just going to test basics about projectile motion. Think of velocity, how it changes. Think of where the acceleration is, right? Imagine gravity as your force. Gravity is always downwards, right? And velocity, it keeps changing, and at some instant, that is at the topmost point, velocity is completely perpendicular to gravity. With all this information, you can try attempting this question, right? So I'll just trigger the second question for you, and yeah, just give it an attempt. 30 seconds, or you need more than that. Okay, anyway, it's a conceptual question, doesn't require a lot of time. But you can have some numericals for 30 seconds. It's a technical glitch. We want to give you more time, but it's a technical glitch. Anyways, this can be attempted within 30 seconds if concepts are clear, right? Okay, most people went for option B. That's not right, right? Option A is right. Why am I saying it's uniformly accelerated everywhere, right? What do you mean by uniform acceleration? When a body is subjected to a force which is not changing its direction and magnitude, which means when a body is subjected to a force which is constant, that force will provide a constant acceleration to the body, right? An acceleration which is fixed in magnitude, fixed in direction, which doesn't change. This kind of motion is known as uniformly accelerated motion, right? And this is how it is for the whole motion, not just at the topmost point. For those of you who have gone for option B, right, this is what you chose. This is wrong, right? When the body is, in projectile motion, at every instant the force is down only, right? And at every point, including the topmost point, at every point the acceleration is g only, g downwards. So acceleration is constant in magnitude and direction. So this is what you mean by uniformly accelerated motion, right? Any motion where acceleration is not changing, either in terms of magnitude or in terms of direction. Any such motion is known as uniformly accelerated motion. That is why the answer to the question is option A, right? Let's see if I can get the time increased for the third question. This is, more or less formula based. So you can give it a quick attempt, right? Okay, so I'm not sure if you will get 30 seconds or you will get more. So that's why I'm just pausing the triggering so that you guys can look at it for a while. Take your pen and paper and start attempting it for 30 seconds, and then I will trigger, right? So you shouldn't run out of time for questions. And yeah, also we started a little late and I have to wind up by 9 because I have a test after that. So we have to be a little quick also. So okay, it's been triggered. I did not trigger it. This is weird. Okay. Anyways, it's triggered now, so you have to attempt. Can't really help it. Okay, just give it a thought. How will you? I know there's less time. I'm telling the team again to increase the time. Anyways, the answer to the question is 14 meter per second, right? Let's try attempting it. I guess I'll have to explain you for some of you who were not able to understand it. A ball is projected with 20 meter per second at an angle to the horizontal, right? In order to have maximum range, its velocity at the highest position must be. Now, you guys should know what is the trick here. If I project a body with some velocity at some angle, it will go in a projectile motion, that we know. When will this r be max? Right, that is the horizontal distance that it covers. When will that be max? That r is max when this theta is 45 degree. For a fixed value of u, this r is maximum for theta equal to 45. And if theta is 45, then at the topmost point, you only have the cos component left, right? There are two components of velocity, right? One is u cos theta and this is u sin theta. When the body reaches the topmost point, it only has u cos theta left. U sin theta becomes 0. That's why that is the topmost point, right? So this is your answer actually. U cos theta is your answer. 20 into 20 is your u. Cos theta, what should theta be? Indirectly they gave you theta by telling that range should be maximum. And indirectly they told you that theta has to be 45. So 20 into cos 45. That is the answer, right? 20 into 1 by root 2 meter per second, which is 20 by 1.414, which is like 200 by 14, right? Try doing it 14, it will go 14 times because you'll have a 196, then you'll have a 4. When you do a point, you'll have a 0 remaining, so it's 14 point something. That's the answer. So that's why the answer is 14 meter per second, right? I hope that makes sense. And we will go to the next question now, right? Let's go to question number 4 quickly. Okay, again I'm giving you some time to see. Let's hope the trigger question doesn't get triggered on its own now. Two bodies are thrown with some initial velocity at angles. Okay, it's mistyped, I guess. This is theta. It should be theta, not 0, right? That's theta, by the way. With angles theta and 90 minus theta with the horizontal, then the ratio of their maximum heights are in the then the ratio of their maximum heights are. That's the question. Let me just confirm it. Yes, the team wasn't able to put the theta symbol, but yeah, there is still a theta, another theta missing in the question also. So two bodies are thrown with the same initial velocity at angles theta and 90 minus theta. That's the question, and I will just quickly confirm it and I will tell you. Right, this is question number 4, isn't it? Okay, questions are getting triggered on their own. Treat it as theta is 90 minus theta. That is what it is, right? Theta is 90 minus theta. This is question number 4, right? Don't treat that as 0. It's theta, right? Right. And options B and C are similar. That's not how it should have been. Anyways, forget about what you're seeing on screen. It's all mistyped. I'll just go and quickly explain it to you, the question, right? So you have one body which is projected at an angle theta and another body which is projected at an angle 90 minus theta, and both are having the same velocity u. So first body is initial velocity u, angle is theta. Second body's initial velocity is u, but angle is 90 minus theta. The ratio of their maximum height is. I hope you know, if you project a projectile, then what is the maximum heights formula? If initial velocity is u and angle is theta, maximum heights formula is u square sine square theta by 2g, correct? U square sine square theta by 2g. So what is the maximum height of the first body? Maximum height of the first body is u square sine square theta by 2g, because velocity is u, angle of projection is theta. What is the maximum height of the second body? It is u square sine of 90 minus theta whole square by 2g, right? Because 90 minus theta is the angle, right? By the way, if you guys don't remember these formulas, then don't worry, you should know how to derive it, right? Even if you forget projectile motion formulas, they're all very easy to derive. You should just know how to use those 3 laws properly, and you should have knowledge of vectors, splitting of vectors, and the 3 equations of motion, accelerated motion. That's all that you need to know to derive all the formulas of projectile motion. So even if you forget, make sure you know how to derive it, right? So the answer, if I take the ratio h max 1 is to h max 2, what will happen? U square will get cancelled, 2g will get cancelled, and I'll have sine square theta is to sine square 90 minus theta, which is cos square theta. So the answer is actually The actual answer is sine square theta is to cos square theta, right? So with this quickly done, I will go to the next question so that you can see it on screen. Okay, this is not even typed. Oh, so then I'll have to, what do? I'll have to tell you. A gun is firing bullets with velocity v0 by rotating through 360 degrees in a horizontal plane. Then the maximum area covered by the bullets is, right? So you have a gun which is throwing bullets with velocity v0, and this gun is rotating by 360 degree, right? So what will happen? A bullet will go to some distance like a projectile and it will fall. When the gun rotates, a bullet will come in this distance and it will fall, right? When the bullet rotates to the left side, the bullet when the gun rotates to the left side, the bullet will take a projectile and it will fall. So in a way, when the gun keeps rotating, bullets will keep making a circle, right? So you have to find the maximum area of the possible circle. That's the question. Okay. So if you just know if you know the formula for maximum range, you can just do pi into range square. That is the formula for the area of the maximum circle. So I'll just draw it on the screen. Okay, this is fairly poor. You can't even see the options. I guess you can, but don't worry, I will give a feedback about this to the team. I will have to give a feedback because we can't see the questions properly, we can't see the options, they are getting triggered on their own. There are lots of problems today, I agree, but just be there to learn. That's the best thing I can say, because I'm explaining you every question, right? So just be there to learn. Okay, so you have a gun. This gun is firing bullets with velocity v0. Okay, what will happen? This bullet will go all the way and it will fall. When the gun rotates that side, bullet will go that side and it will fall. When the gun rotates this side, bullet will go this side and it will fall, right? So this way all these bullets can cover a circular area, right? Now what is the maximum area of such a circle possible? If you want to maximize the area of the circle, you have to maximize the radius. If this radius is maximum, then the area of such circle will be maximum. Gun is rotating like this, it's throwing bullets, it's making a circle. So what is the maximum range possible, right? Formula for range is v0 square sine 2 theta by g, right? That is the formula. And if you want to maximize range, then the sine 2 theta has to be 1, which means theta has to be 45, right? We have already seen this in one of the previous questions. So range is v0 square by g, correct? This is the maximum range possible. So what is the maximum area possible? Maximum area possible is pi into maximum radius square, correct? Which is pi into this quantity's square, v0 square by g whole square, right? So maximum area is pi into v0 power 4 by g square, right? Which is option C. That's why the answer to the question is option C. I'm pretty sorry about the fact that you're not able to see the questions, and also options are, you're getting less time to attempt. I'll quickly show you the next question and I will read it also. I'll draw the diagram as I say. A body is projected at an angle 60 degree with horizontal with kinetic energy K. So you have a body which is projected at an angle 60 degree and it is having a initial kinetic energy K, right? So indirectly they have given you velocity. When the velocity makes an angle 30 degree, so when the body comes here and when the velocity makes an angle 30 degree, then at that time what is the kinetic energy of the body? Here what is the kinetic energy? That is the question. Okay. So how will you solve this? This is the question. Just give it an attempt. Shouldn't be really difficult. There are multiple ways you can do this. You can do this using work power energy also, but since we are with kinematics, I'll tell you the kinematics method to do it when I explain you the solution. Okay, the options are not getting triggered. That's a good news for us, I guess. So now I can manually trigger them, which I just did. Yeah, so now you can attempt. Right, and now let me tell you the solution for this. So it's pretty simple, just imagine the velocity to be v. Okay, so at the bottom you have a v cos 60 and you have a v sin 60. So here you have a v into v by 2, here you have a v root 3 by 2. So your kinetic energy k is half m v square, right? This is what it is. Okay, half m v square. And when the body comes here your velocity is v dash. Okay, here it's v dash. So let the kinetic energy be k dash over there. So k dash will be half m v dash square. Okay, so when you take the ratio of these two, not ke, I need k here. So k by k dash will be equal to half m will get cancelled. You'll have v square by v dash square. But there's one thing that I can say. Horizontal component of the velocity never changes, right? Horizontal component always remains the same. So here the horizontal component is v cos 60, and at 30 degree here the component is v dash cos 30. So this v cos 60 has to be equal to v dash cos 30. Why? Because there is no acceleration in the horizontal direction. So horizontal component of the velocity never changes. So from here I can get the ratio of v by v dash, right? So v by v dash from here, what will it be? Cos 30 by cos 60. Cos 30 is root 3 by 2 and cos 60 is 1 by 2, correct? So this is root 3. So k by k dash square is root 3 square, which is 3. So k by k dash is 3. So k dash is k by 3, correct? Simple it was. You should just know the concepts of projectile motion to attempt problems, right? Let's go to question number 7 now. And since you can't see it again, I'll just put it. The range of a projectile at an angle theta is equal to half of the maximum range if thrown at the same speed. So you have a projectile which is projected at some angle theta with a velocity u. Let its range be r. Okay, now this range is equal to half of the maximum range if the velocity is thrown at the same speed. If the body is thrown at the same velocity. So it's thrown at the same velocity, and if it's thrown at 45 degree, then it will have r max, right? So this r max, it's given in the question that this r max is equal to r by 2. This r max is equal to 2r, right? So from this information you have to find theta, right? So I have put the whole thing in front of you. You are projecting a velocity object with velocity u, angle theta, right? When you keep the velocity same, but you project it at an angle so that range is maximum, then that maximum range is twice this previous range. So when is range maximum? When angle is 45. That's why this is 45, right? So with all this information, try attempting this. Trigger it. Okay, it's got triggered on its own. Anyways, I'll start explaining it, right? So again, what is the formula for range? We know that. And by the way, that's first option is not 150 degrees, it's 15 degrees. Oh my god, can't believe the number of mistakes that are there on the PPT today. So you have range is equals to u square sine 2 theta by g, and here your R max is u square sine 2 into 45, which is sine 90 by g, right? And it's also given that R by R max is 2, is half. R by R max is half. So what is R by, when you do R by R max, u square will get cancelled, g will get cancelled, right? So you will have a sine 2 theta. If sine 2 theta is half, then 2 theta is 30 degrees and theta is 15 degrees, right? That's why the answer to the question is 15 degrees, and 150 degrees what you are able to see on the app. Forget about that, you know it's wrong, right? Let's move to the next question. So if T1 and T2 are times of flight for two complementary angles, then the range of the projectile is given by. Very simple question. So you have a projectile with a velocity u if you project at an angle theta, right? Then the total time of flight is T1. The same projectile, if you project it at an angle of 90 minus theta, then the time of flight is T2, right? So with this information given, you have to find the range of the projectile. Then the range of the projectile R is given by, yeah. How do you get the range in terms of this, right? And the best hint is just use the formulas for time of flight, and from those formulas try getting range if you can, using some trigonometry from maths. Right. So here it is. Okay. So what is the formula for time of flight? Let's see that. So it's question number 8, right? Forget about the answer, guys. Again, this answer also looks dimensionally wrong. I'll just explain it to you. So what is T1? So first of all, when you have a projectile with a velocity u, angle theta, what is the formula for time of flight? 2u sine theta by g, right? You guys know this? Very simple to derive, you know, using splitting of vectors, knowledge for splitting of vectors, and those three equations of motion, you can derive this, right? So 2u sine theta by g. So in first case, your T1 is 2u sine theta by g. So this is T1, 2u sine theta by g. What is T2? T2 is 2u sine 90 minus theta by g, right? Because T2 is for angle 90 minus theta. This theta changes to 90 minus theta. So here you have 2u sine theta by g. Here you have 2u cos theta by g, correct? Now do one thing. You can see T1, T2, T1, T2, T1, T2 in all these options, right? There is a G missing in the option that's given as the key. So if you are able to see T1, T2, just do T1, T2 here, right? So you'll have 4u square by g square into sine theta cos theta when you do this into this, right? In this, what you do, you take u square sine 2 theta by g, right? How did I get a sine 2 theta here? How did I get a sine 2 theta? You'll have a 2 also, right? 2u square sine 2 theta by g. How did I get this sine 2 theta? You know the formula, right? Sine 2 theta is 2 sine theta cos theta. So I extracted 2 sine theta cos theta from here. That will leave me with an extra 2. That's why you have a 2u square sine 2 theta by g, right? Now what will I do? Once I have this with me, I know the formula for range is this u square sine 2 theta by g, right? There is a g square, by the way, you have a g square. So I'll take 1g out and 1g I'll keep inside. So this will become range. So T1 into T2 will become 2 times range by g. That's why range will become half g T1 T2. That's why the answer is this. There is a g missing in your option. right? Whenever you see such products, then put the formula and then see what that product is, and then try to lead that to the quantity that you wanted. That's how you solve questions like this, right? Let's move on to the second last question, which is the 9th question. A grasshopper can jump a maximum distance of 1.6 meters. It spends negligible time on the ground. How far it can go in 10 rows per second? So it's like this grasshopper, there is a grasshopper, he can jump like this, like a project.